Claude app passes demos long before it deserves production traffic. Week 6 matters because CCA-style scenarios test architecture judgment, safety, reliability, deployment, evaluation, governance, and cost control are key. Real constraints challenge your ability to design robust systems. The goal is no longer just making Claude answer, it's designing a system that keeps answering correctly when users' data, tools, latency, compliance, and risk all change at once without needing heroic manual supervision. Most prototypes hide failure behind a beautiful response. They depend on one prompt and one happy path. One developer watching the output isn't enough. Claude operates within a larger system. APIs can fail at any time. Context drifts over time. Tools may return partial data. Policies change unexpectedly. Logs become evidence of real issues. Users find edge cases faster than teams can fix them. The model is not the architecture. The architecture is the control system around the model. Production teams must decide what enters context. They must choose which tools are allowed. They must determine when to refuse a request. They must plan how to recover from errors. They must decide where to log evidence. They must ensure quality can be proven after release. Without these controls, intelligence becomes improvisation, and improvisation becomes operational risk. Risk disguised as innovation at scale. Claude safety is built into every request. It's not an afterthought, it's a core layer. Constitutional principles guide every interaction. System policies enforce consistent behavior. Input classification ensures proper handling. Tool permissions are strictly controlled. Human escalation is available when needed. Audit trails track all actions transparently. The mindset shift is critical. Teams no longer ask if Claude is safe overall. They now prove each workflow is safe enough for the specific task at hand, for the data boundaries involved, and for the user population using it. Reliable Claude systems start before the response. They begin at the intake stage. The request gets classified first, then it's normalized for consistency. It's scoped to define clear boundaries, enriched with relevant context, routed to the right component, checked for validity. Only then does the model generate a token. This is the breakthrough. Quality improves when ambiguity is reduced upstream. Claude performs best with structured architecture. It turns messy intent into bounded tasks. Tasks have verifiable outputs. Fallback paths are built in. Completion criteria are explicit. Assumptions are monitored continuously. A durable Claude architecture separates concerns. The application layer owns the user experience. The orchestration layer manages prompts and model selection. It also handles tools, retries, and fallbacks. The context layer manages RAG and memory. It handles caching and citations too. The governance layer manages safety and access. It controls retention, monitoring, and evaluation. Each layer limits blast radius when changes occur. Changes in data models or permissions stay contained. Production design treats tokens, latency, and rate limits as first-class constraints. Prompt caching ruses stable prefixes to reduce repeated processing. Anthropic notes batch cache hit rates range from 30% to 98%. Hit rates depend on traffic patterns and workload characteristics. The exam mindset is simple. Match the model to the workflow. Choose context, cache, batch strategy, timeout policy, and degradation path wisely. Let the workflow guide decisions, not personal preference. Function calling isn't permission to let Claude improvise with infrastructure. Every tool must have a narrow, well-defined purpose. Parameters should be strictly typed and validated. Actions must be idempotent to ensure safety. Authorization checks are required for every operation. Timeout handling prevents hanging processes. Outputs must be observable and traceable. The system should make dangerous actions harder than safe ones. Reversible actions should be cheaper than irreversible ones. When behavior is contractual, Claude acts as an operator within guardrails, not as a narrator pretending to execute. Production quality must be based on data, not vibes. Evaluations define inputs and expected behavior up front. They set grading logic and failure thresholds before release. Anthropic views evals as tests for AI systems. Give an input, apply grading logic, measure success. Golden datasets turn past edge cases into future regression protection. CI pipelines prevent prompt changes from shipping silently. Without evals, every prompt update is a silent migration. A strong CCA-style answer explains trade-offs under pressure. It identifies the risk in a given scenario. It isolates the failure mode clearly. It chooses the right architecture pattern. It justifies the chosen model effectively. It defines clear evaluation metrics. It adds proper monitoring mechanisms. It states when human intervention is necessary. The best answer names what not to build. Production maturity means removing clever complexity early. Avoiding unnecessary complexity prevents future incidents. As Claude apps scale, governance becomes the organization's memory. Data retention rules shape how long information stays. Access boundaries define who can see or change data. System cards track key details about each system. Incident reviews help learn from past issues. Prompt versioning keeps track of changes over time. Eval history shows how responses were tested and improved. Deployment approvals ensure changes are reviewed. These practices make decisions inspectable and traceable. Trust isn't built by a single correct answer. It's built when teams can explain why the system acted that way. They can show who approved the decision and prove the system is improving over time. Week 6 closes the loop. It ties together scenario, architecture, and controls. Evaluations, deployment, monitoring, and review follow. The mock exam prepares you for the real job. Shipping Claude safely is the goal. The future belongs to builders. They connect intelligence with accountability, not the loudest prompt engineer. The architect who makes Claude reliable, even when no one is watching, and can explain the system safely when everyone is asking hard questions.